Kia ora and good morning. Not that long ago, a colleague of mine said that they felt that climate change would be net positive for the forest industry. Increased temperatures and higher CO2 concentrations would lead to improved growth and hence improved profitability. Climate change will show its face in a number of different ways, and after listening to this presentation, hopefully you will see a different face of climate change. The problem for us wasn't climate change per se, it was actually harvest recoveries. So that's the relationship between the volume that we were predicting and the volume that the harvesting crews managed to put across the weighbridge. What we found about 10 years ago was that our harvest recoveries fell, and they fell in ways that we were unable to explain fully. Initially, we thought it was related to mechanisation, and it would just take some time for our harvest crews to adapt to the new methodologies. Over time, our harvest crews adapted to the new methodologies, but our recoveries didn't improve. And over time, we weren't finding that volume sitting on the cutover. Anecdotally, there was also more trees standing dead when the harvest crews went into to clear fell than our inventories were actually telling us. And more recently, certainly over the last 3 to 4 years, we've found that our growth models were no longer predicting accurately growth. What we were finding is that our growth models were tending to over-predict the volume that was actually there to be harvested. We hypothesized. We had three hypotheses. The first was, were we overstocking our stands? And certainly in the last 15 years, our average harvest age has lifted from 25 years to 30. And at the same time, our final crop stocking has lifted from around about the 250 stems per hectare to in excess of 400 stems per hectare. So clearly our stocking levels have gone up, but also we're starting to think about dry periods, and this isn't so much about have we had really good summers, but I've had a couple of trips now to South America, and in Brazil in particular, but not exclusively there, their dry period has gone from 1 month to 4 months, and you can imagine the impact of that on tree growth. We also wondered about our models, the models that we've tended to use historically, ppm 88, produced obviously in 1988, and the 300 index, which was last reviewed probably 10 or 15 years ago. And we wondered if the new genetics were growing differently, or perhaps our current final crop stockings are more at the extreme end of the data that went into those model builds. Back in 1988, final crop stockings probably averaged 200 to 250 stems per hectare, whereas now we're looking in excess of 400 stems per hectare. So if we look firstly at overstocked stands, most of you will be familiar with the stand management diagram. If your stand density is below the dotted line, it's understocked. If it's above the dashed line, it's overstocked. And when you're in that overstock zone, or I call it the death zone, you start to get competition-based effects, reducing growth, but also increased mortality. And for us, with our increase in our average harvest age, also the increase in the average stocking, we're finding ourselves, or our stands are spending more and more time in that death zone. So I think clearly we are overstocking our stands. We then looked at drought, and a colleague once, or quite recently actually, said to me, Ian, you can always see the impact of drought in the pasture or in the crop because it goes brown, but you don't always see it in trees. And the example here on the right hand side is in the Yosemite Valley, which is in the high country of California. Most of us know that California has been in a drought for a number of years, but even in the high country where you expect more rainfall, we're seeing the impacts here directly of drought. So drought is killing those trees, as well as the secondary impacts of disease and insects brought about by the stress of drought. We're fortunate here to have Scion, and this is a trial in southern Kaingaroa. It's part of the Accelerator trial series. And here we have linked together dendrometer bands, so we can very accurately get tree growth right down to every minute or every 15 seconds, I think. We also have associated with a weather station. So we can actually start to link that information together, and you can see on the right hand side the table or the graphs, sorry, that show water deficit and the related growth when you go into water deficit. Just imagine if you multiplied those numbers by not 1 hour or 1 week or even 1 month, and all of a sudden those periods of water deficit became several months. You can see the impact that you're likely to have on tree growth. That forced us to look a little bit further, and so we grabbed NIWA's database, and we looked to understand how rainfall or rainfall patterns have changed over the last, I guess this is the last 60 years. If you look at the colours, blues tend to be more rainfall than average, reds less rainfall than average. What would be nice is a mix of the pastel greens and yellows. But clearly you can see since 2013 that we've been in a sustained period of less rainfall than normal. Having shown that in all likelihood we are overstocking our stands, certainly too high a stocking for too long, and that we are in the middle of a dry period. Certainly the last 10 years have been a lot drier than at any point in the last 30 or 40 years. We went back to our permanent sample plot database to see what that data might be able to tell us about what's actually happening to tree growth. What we found is that up until 5 to 10 years ago, our models, so that's ppm 88 and 300 index, were working pretty well. But since then, in particular, they've under-predicted mortality, but they've also started to over-predict tree growth or volume growth. And it appears, and I say appears because we've got a little bit more work to do, but it appears that our site productivity or site potential is actually reducing as a result of climatic conditions, particularly in this case drought. So what have we found through all this work? Look, it's clearly getting drier. The last 10 years shows that, but what is surprising is how quickly the climate has changed, even for a maritime climate like we have here in New Zealand. Our forests are probably overstocked for the sites that we occupy. Water holding capacity of pumice and scoria is lower than other sites, and particularly now that we're getting less and less rainfall, overstocking, and that's a mix of the final crop stocking and rotation age, probably needs to be looked at further. Signals are there that we're getting higher mortality and tree growth is slowing. And I think it's clear we need to know more. We don't know enough about the future. We don't know what the climate will be like going forward. We can presume it will be dry, but will it be drier? Temperatures will certainly be higher, and a lot can happen in a 30-year radiata pine rotation. And I think the learning for us will be that the practices of the past may not be the practices of the future. So what next for us? The first thing is we need to understand more than we understand today. So environmental monitoring, we need to understand more at a micro level the climate that we're operating in. We, over the last year, put out 3 weather stations within the forest. We expect to put another 3 out in the next 6 to 12 months, and I think we'll end up with a suite of 10 to 12 weather stations throughout the forest. We should be able to take that information, interpolate and link it to things like soils. We're sampling the soils in all of our permanent sample plots as we get round to remeasuring each. We're probably going to put more permanent sample plots in. I think we'll increase the frequency of measures in some of those permanent sample plots. In late rotation, when you're measuring them every 3 to 5 years, that's just not frequently enough to relate back to changes in the environment. And also genomics. We will be linking the genotype to the phenotype and to the environment, and work that science started in that space. We're certainly planning to continue to develop that thinking and the learnings that will come out of that. And what will come out, we think, are new growth models. So we'll be better able to understand the interactions of climate, site, genetics, and ultimately silviculture. And what that will help us to do is to develop mitigations to the problems that we're finding today that are only going to get worse as the climate continues to adjust or adapt. So now we get to the future thinking, although some of this is work that we're already doing. What might the forest look like in 20 years' time? Look, I think quite quickly we'll end up with different or new silviculture. When I say new, it's actually, we'll probably go back to the past a little bit. I expect thinnings will be a core part of this. I expect we'll end up with lower final crop stockings, and we'll have more frequent or multiple production thinnings. And that will just enable us to keep the forest growing within the optimum zone within the stand management diagram. And I think that rotation lengths will also be affected. I don't believe we'll be running rotation lengths of 30 years for too much longer. I think it'll be a mix of lower final crop stockings and lower rotation ages. Will keep our forests out of the death zone as much as possible. I think nutrition will be a key part of moving forward. If you feed a person well, they're able to handle the stresses of life, less likely to get diseases and the likes. Trees are no different. I think there'll be more work understanding the soil and plant biome, and nutrition will be a core part of the work that goes on there. It's likely there'll be changes in genetics and species choice. There's an opportunity to use genomics and other techniques to future-proof radiata pine for drought tolerance, disease tolerance, and maybe even to reduce the impact of stresses on the trees. I think there will be new species, particularly short rotation species. One of the dilemmas with radiata is how long it takes to grow it and how long it takes to adapt the genetics. I think there will be an opportunity for particularly short rotation hardwoods to fill some gaps in a broader portfolio, and I think there will be new products. At the moment, a lot of the product that comes out of radiata pine goes into the residues, which is effectively cardboard, goes into 4x2s for housing, and not a lot else. I think we'll see more opportunities with radiata on shorter rotations, and more opportunities with other species, and the product mix that comes out of our trees will change dramatically. That's all I had to talk about today. I think climate change is real. You can argue about what's causing it, and certainly in our forest it's having a detrimental impact on the growth of our forests. That said, there's plenty of exciting opportunities to mitigate those negative impacts. Thank you.